This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
When a laptop that's built to be taken apart suddenly gets a serious performance boost, the ripple isn't just for tinkerers, it changes the whole conversation about what a budget machine can actually do. The new Framework Laptop 12 does exactly that, swapping its entry-level Core i5 for a 13th generation Core i3-1315U and adding a host of upgrades that make it a surprisingly powerful platform for anyone who wants to run code, run models, and run a network of AI inference nodes without breaking the bank. First, let's unpack what's inside the new Laptop 12 and why each component feels like a deliberate answer to the community's most common requests. The headline change is the Core i3-1315U, a 10-core chip that blends 2 performance cores with 8 efficiency cores. On paper that sounds like a downgrade from an i5, but the architecture is actually a step forward. The efficiency cores are optimized for parallel workloads, meaning they can chew through many small threads at once while keeping power draw low. Pair that with up to 32 GB of LPDDR5 RAM, still user replaceable through the familiar 260-pin slot, and you have a machine that can keep dozens of containers, virtual environments, or IDE windows open without resorting to swap space. Storage gets a similar makeover. The new M.2 2280 slot now supports PCIe 4.0x4, so a 2 TB SSD can saturate the bus at up to 5 GB per second. That's not just a nice number for moving files, it translates into lightning-fast model checkpoint pulls, rapid container image loads, and virtually no lag when you're juggling large datasets. The battery also grows from 55 Wh to 61 Wh, a modest bump that, combined with the low TDP 15-watt base of the i3-1315U, stretches real-world usage to well over 12 hours of mixed work, browsing, and light inference. On the display side, Framework finally gave the screen the brightness it deserves. A full 1080p IPS panel that pushes 400 nits with a 3:2 aspect ratio that gives you more vertical real estate for code editors and terminal windows. All of these upgrades sit inside the same thin and light chassis that weighs just under 3 pounds, and the modular design remains untouched. Batteries, SSDs, even the keyboard can be swapped without voiding the warranty. Now that we know what's under the hood, the next question is how those specs translate into real-world performance. In synthetic tests like Cinebench R23, the i3-1315U lands around 5,500 points on the multi-core score, roughly 15 to 20% higher than the previous i5-1235U. That gap may seem modest, but the true story emerges when you look at workloads that actually matter to developers. A simple Python script that parses a CSV, performs a few transformations, and writes the result out took 12 seconds on the older model. On the new Laptop 12 it finishes in about 9.5 seconds. That's a tangible time saving you can feel every day. When it comes to AI inference, the difference is even more pronounced. Running a lightweight TensorFlow model on a 224 by 224 image dropped from 78 milliseconds to 62 milliseconds. It's not the kind of speed that will replace a dedicated GPU, but on a device that costs under $800 it means you can prototype, test, and even serve small models locally without needing a cloud instance. The 8 efficiency cores shine in parallel tasks, compiling a medium-size Rust project, building a Docker image, or running a batch of 10 inference Calls all see noticeable speedups because the scheduler can spread the work across those low power cores while the two performance cores handle the heavy lifting. The larger battery, too, isn't just a vanity metric. It gives you longer uninterrupted sessions, which is priceless if you're on a train, in a coffee shop, or in a remote cabin with spotty power. But here's where the story gets interesting for the everyday developer who spends most of the day switching between an IDE, a terminal, a browser, and a handful of local services. The Laptop 12's balanced CPU architecture means multitasking feels smoother. You can have VS Code open with a massive workspace, a Jupyter notebook running a data cleaning pipeline, a Docker Compose stack with a Redis cache and a tiny Flask API, and a couple of browser tabs for documentation, all without the dreaded "your computer is running low on memory" pop-up. The extra RAM capacity eliminates the need to constantly hit the SSD for swap, which not only speeds things up but also reduces wear on the storage media. And because the NVMe slot supports PCIe 4.0, pulling a 10GB model checkpoint from a remote repository takes seconds instead of minutes, shaving time off the iteration loop. Connectivity is another area where the Laptop 12 pulls ahead of many competitors in the same price bracket. Two Thunderbolt 4 USB-C ports give you up to 40 gigabit per second bandwidth, which means you can hook up an external GPU enclosure when you need that extra horsepower for a heavy model or a batch inference job. The modular expansion slots let you swap a simple USB-A module for a full-size HDMI output, a 2.5 gigabits Ethernet adapter, or even a custom I/O board that a hobbyist might design for sensor integration. The ability to attach an eGPU isn't just a gimmick, it creates a clear upgrade path. Start with the internal CPU for everyday tasks, and when a project outgrows the laptop's native compute, plug in a modest external GPU and you've effectively turned a $800 notebook into a flexible edge node that can handle more demanding workloads. So far we've covered hardware, performance, and day-to-day productivity. Now let's connect those dots to why this matters for decentralized AI inference networks like ChainMind. ChainMind's architecture relies on a mesh of edge devices that collectively serve model predictions, distributing load to keep latency low and energy consumption efficient. The key metrics for any node are compute throughput per watt and the ability to tailor resources to the specific model you're serving. The Core i3-1315U, with its 15-watt base TDP and a boost ceiling of 28 watts, delivers more inference queries per watt than the previous generation, directly improving the network's carbon footprint calculations. In practice, a node that was handling, say, a small vision model at 150 inferences per second on the older laptop can now push closer to 190 inferences per second while staying within the same power envelope. Because the Laptop 12's RAM and storage are fully modular, operators can configure each node exactly for the model they intend to run. A language model node might be provisioned with 24 GB of RAM and a 1 TB SSD to accommodate a 3 billion parameter transformer, while a pure vision node could run comfortably on 8 GB and a 512 GB drive. When the model evolves, perhaps a newer version adds a few hundred million parameters, the operator can simply upgrade the RAM or swap in a larger SSD without replacing the entire chassis. This flexibility reduces the total cost of ownership dramatically. Instead of buying a new, higher-spec laptop every year or every 18 months, you only replace the component that becomes the bottleneck. That brings us to sustainability, a principle that sits at the heart of both Framework's philosophy and ChainMind's mission. Framework has built an entire ecosystem around right to repair, a comprehensive spare parts catalog, detailed service manuals, and a vibrant community. Forum where users share repair tips, firmware tweaks, and custom mods. From a waste reduction perspective, the ability to replace a battery after 500 charge cycles, swap out a failed keyboard, or upgrade the storage means the device stays in service far longer than a sealed-up competitor. For a decentralized AI network, that longevity translates into lower operational expenses and a smaller environmental footprint. Operators can keep a node alive for 3 years or more, only refreshing the parts that become outdated as AI models grow. When you line up the laptop 12 against other sub-$1,000 laptops, the differences become stark. The Lenovo IdeaPad Flex 5 offers a similar Core i3 processor but comes with a lower-grade 250 nit display, a non-removable battery, and a convertible hinge that adds mechanical complexity without adding real value for developers. The HP Pavilion 14 ships with an AMD Ryzen 5 5625U, which is a solid chip, yet the chassis is not user-serviceable and the warranty explicitly excludes self-repair. Acer's Swift 3 might give you a Core i5-1240P, but it lacks the modular ports and sealed-in battery that make upgrades and repairs a hassle. In each case, you're forced to choose between raw performance and the ability to maintain, upgrade, or repair the device yourself. Framework refuses to make that trade-off. It delivers a balanced mix of performance, upgradability, and openness at a starting price of $799 for the base model. Adding 16 GB of RAM and a 1 TB SSD pushes the price to roughly $1,099, still well below the $1,300 to $1,500 range of comparable Windows Ultrabooks. When you factor in the cost of spare parts, often under $100 each, the 3-year total cost of ownership can be 30 to 40% lower than a sealed competitor that forces you to replace the whole laptop when a component fails. The community that rallies around Framework is another hidden asset, especially for a decentralized network like ChainMind. Thousands of users on Reddit, Discord, and the official forum share custom case mods, firmware hacks, and even alternative operating system installations. The Laptop 12 has already sparked projects ranging from e-ink side panels that display system health metrics to AI-accelerated edge nodes built with external GPUs and USB-C based accelerators. For ChainMind, this means a ready pool of potential node operators who are already comfortable with hardware tinkering. Swapping a storage module to install a specialized inference engine, or plugging in a USB-C accelerator, becomes a straightforward, low learning curve task rather than a barrier that discourages participation. Looking ahead, Framework's roadmap hints at a future where the laptop chassis becomes a universal compute shell. Upcoming revisions may support ARM-based processors, and the modular port system is slated for a redesign that could accommodate PCIe 5.0, unlocking even faster external accelerators. If those plans materialize, the Laptop 12 could serve as a bridge between today's entry-level AI workloads and tomorrow's more demanding models, all while retaining the repair-first philosophy that makes it unique. In a market that's increasingly demanding affordable, capable edge devices, Framework's approach demonstrates that you don't have to sacrifice performance to get openness and sustainability. To sum up, the Framework Laptop 12